All right, what's up, boys and girls? Welcome back to the drive-through. Why is this thing so small? What did I do to it? I don't know, but we're going to go with it. So I like this question. It makes me understand things a lot better. So let's just say that this object is at the origin. Okay. So let's make our XY axis, and let's say we have one. Oh, that's white. I can't do white. Okay. So you got a 10 pounds. So, up until now, most of our magnitudes have represented wind speed. But we can have them represent whatever we want. So now they represent pounds. So you got 10 pounds in that direction, and you got 10 pounds in this direction, and they're 90-degree angle between the two of them. So we need to give these things angles. Well, luckily, we're all over this because we're starting to get better at this. So we know that this would be 10 cosine of 0, 10 sine of 0. Hopefully you know what that is, but I'll fill it in here. That's the purple one. And then we know that the orange one would be 10 cosine of 90, comma 10 sine of 90. Well, the fact is you don't need SOHCAHTOA to do this. You know that this purple one is 10 comma 0. But now you just recognize that the cosine of 0 is 1 and the sine of 0 is 0. Similarly, you know that this one up here has to be 0 comma 10. Okay, so if we pull 10 pounds in one direction and 10 pounds in the perpendicular direction, what will the resultant force be? We'll define the result. We just do sum up our two components and you end up with 10 comma 10. Well, that makes sense. Where is that? It's right there. Okay, now what do they want? They want the magnitude of the resultant and find let's see. Yeah, so they just want the size of this. So that's going to be the square root of 200, which is 10 radical 2, or I don't know, like about 17.1 pounds of force. Okay, so that's the first one. The second one, now they're at an angle where the first one, I always put the first one right along the origin because it's an easy one to come up with. And the second one is there. So once again, this one is 10 comma 0. And this one is, well, 10 cosine 135, 10 sine of 135. Okay. So let's go ahead and write that out just so you guys have something that makes a little bit more sense to you. Putting this in my calculator. So you get negative 7.0716. And then when you do 10 sine of 135, you're going to get positive 7.0716. So now what do we got to do? We got to add these things up. So this one plus that one, and that's going to be our resultant vector. So our resultant vector must be, what's 10 minus 7.0716? It's going to be 2.9284, comma 7.0716. They want to find the magnitude of that, so I got to do the square root of x squared plus y squared. You end up getting 7.65. Okay. So notice that's less than either one of them were pulling on their own. But what that means is that their forces, since they're traveling in opposite directions, are counteracting each other. So I bet the last one is going to be even smaller. Okay. So now I think I could probably, let's see, do this a little quicker. We got 10, 0. And this is 10 cosine 170. This one right here is 10 cosine 170, comma 10 sine 170. So you get negative 9.84, 80, comma 10 sine of 170, and you get 1.7364. Okay, so now what am I adding that to? I'm adding this vector to this vector to get our resultant vector. Oh, I'm starting to see what's going to happen. This gives you 0.15922. And the other one is 1.7364. And if you notice the angle that these two vectors are at, they're almost completely pulling in opposite directions, which will completely counteract their force. Okay, so the magnitude of R is the square root of x squared plus y squared. It's just Pythagorean theorem where this is x and that's y. I'll just do that in my calculator. And you end up getting 1.7437. So notice, of all of them, that's the lowest resultant force. I hope this helps. Thanks for your question, Jason. Boom!